Today I'll be presenting our group's Fleetwood challenge submission. So the title of the proposal is the upcycle apartments. So going into the challenge, we sort of started off with a bit of research into the suburb of Malvern East, looking what was essential for the suburb and what sort of looked into the site context essentially. So we found that there was a lot of sort of this large commercial strip along the main road there with quite easy access to public transport, having the tram stop just outside the site and the station not far away, along with the the Monash University campus within the 100-meter radius of the site. Along with that, there's quite a bit of noise pollution at being a main road with public transport line there. So we sort of had these things in mind when we were designing. So we sort of started off with an initial concept. So essentially a basic massing, which is sort of a linear block, which we felt suited the site quite well, giving sort of a lot of ventilation and sunlight into the site, because it is obviously there's a lot of overarching shading from a lot of large vegetation and trees, and across the road having quite some tall apartments and things. So yeah, so then we built upon this sort of like a concept of a few concepts that we want to dive into. So the ideas of circular economy, designing for disassembly, the use of recycled and renewable materials, and sort of off that extending product's lifespan. So thinking of ways that we could use materials and components that could then be disassembled and used for another use or building. And then obviously that goes under the umbrella of designing for multiple life cycles. So then we sort of developed this sort of timeline, which starts with upcycling and acquiring materials, refurbishing where required. So if we're recycling, say, a piece of timber, it'll be sent off to be refurbished and then be bought to be manufactured off-site, transported onto site, and the parts put together on site and then disassembled when needed. So the main materials we sort of used were concrete, brick, timber, steel, zinc, and glass. So things like brick and timber, we thought there is quite a bit of it on the existing site. So we thought that this could be used and sort of upcycled to sort of represent the concept, the sort of like the main concept that we worked with in the proposal. So we sort of designed sort of like a feature on the ground level, having the upcycled materials utilized. So then obviously we attempted to go for sort of a net zero design. So looking into ways we can lower our carbon emissions and things. So then we looked into ways we can design for disassembly. So we looked into various connections and ways we can assemble the building that is easy and efficient, and is also easy and efficient to disassemble. So we worked with sort of beams and columns. So the building would be first assembled with all the beams, and the platforms will then be slid into the beams, and then the structures would be then put on top. So it makes it quite simple and easy, where we have sort of this bones, and then all the spaces are sort of slid into this bones of platforms and beams. So to make things sort of cheap, easy, and efficient, we kept things quite standardized. So we sort of developed a material and component catalog. So we developed, I think it's 16 things that we got on the catalog. So everything is built utilizing these 16 things. And this also was good because we tested a few other basic configurations of if things were to be disassembled, how we could then assemble them again to create a new space. So this sort of strengthened our idea of sort of upcycling and sort of designing for multiple life cycles. Yeah. So then we started off with sort of the initial design. So the module is 2 levels, and the ground level being the area for the communal space, and 4 single bedded units. And the first floor holds the units, and the second floor with 4 units with common amenities for the residents. The design essentially focuses on, as I said, easy assembly and disassembly, where the toilet areas are put in sort of as volumetric structures. So everything is put in as sort of individual walls and slotted in, except for the things like the toilets are sort of brought in on site as volumetric structures and slid into the spaces. So here's sort of a few of the logistics. It is a bit difficult to see, but essentially we, I think it's a 22-week process of installation and things. So we try to keep it as short and efficient as possible to cut costs as much as we could. So keeping things standardized helps with this a lot. So things can be sort of pushed out easily, and limiting customization and difference between spaces makes it very efficient and easy. So yeah. So this is sort of the bit of the structural analysis we did. So we just made sure everything was up to code there with the this 240 CLT timber beams that we did. So that holds most of the load. So we just sort of had a lot of playing around with that, with the size of the beams and the amount of them. So lastly, here are some of the services. So obviously fairly straightforward stuff. So there's centralized heating and gas in the top of the structure that heats all the living spaces. That's it there, along with a grey water system, electrical. There at the bottom are some renders. So we got some daylight analysis, and these are the floor plans here. So on the ground floor is a few things. So there's a lot of open and courtyard space. So to assist in sort of lowering the cost for the residents, there's a lot of cafes, sort of spaces to make money for the sort of activating the public amenity space. So sort of like a study space for people to come, along with a cafe and sort of garden spaces. Yeah. And there's some other plans, a section, and along with that, things like laundries and courtyards are all shared. So this sort of assists in making the private living spaces a lot smaller and efficient. Yeah. And these are the last visualizations we did, so we can see. That's all. Thanks for listening.